I'm Lily Bovim, and I'm going to be presenting the work I've done using satellite telemetry to describe the temperature and depth preferences of Argyrosomus regius, also known as Meagre, in the northeast Atlantic. Studying the temperature and depth preferences of marine fish can improve our understanding of their ecology. Fish experience much larger changes in oxygen concentration, temperature, and light, for example, moving vertically in the water column in comparison to moving horizontally. And these factors influence their habitat choices while they fulfill their biological requirements such as foraging, reproduction, and predation avoidance, while also under the constraints of their physiology in relation to these environmental factors. Also, temperature is a strong determinant of fish distribution, meaning that understanding thermal preferences can help us to explain and predict their response to climate change. Furthermore, depth preferences are used in catchability estimates, which are then used in population assessments. Meagre is one of the largest Scianidae species, reaching over 185 centimeters length and 58.5 kilograms. They occur in the eastern Atlantic, predominantly between France and Senegal and in the eastern Mediterranean. And they inhabit epipelagic waters and are predominantly demersal. Like other Scianids, Meagre migrate into estuaries and shallow coastal waters to aggregate and spawn in the summer. Their 6 known spawning areas are indicated with black asterisks here. And after the summer, the adults move to deeper waters, but there's very little known of their winter distribution. Although Meagre have a wide thermal tolerance, they appear to be sensitive to water temperature, as their reproduction and spawning migrations seem to occur in response to warming waters. Meagre are an important small-scale commercial and recreational fishing resource, but despite this, little is known of their ecology. Although they're listed as the least concern by the IUCN Red List, Meagre have characteristics, many of which are shared with other Scianidae, which make them vulnerable. For example, they're heavily targeted during their noisy spawning aggregations, and as I mentioned, this only occurs in 6 areas, meaning that they rely on the good environmental condition of very few sites. Furthermore, the unusually high genetic fragmentation of the European Meagre population further adds to their vulnerability. They're also often caught before maturity, and like related species around the world, they're prone to overfishing, and they've already become extinct in some areas, such as the Western Mediterranean. Despite these concerns, there is no formal population assessment or management plan for Meagre. Basic knowledge of species ecology is essential for adequate fisheries management, and satellite telemetry can be used to sample the in situ vertical and thermal habitat of wild fish as a method of gaining this knowledge. Pop-up satellite tags are attached to fish and record information such as temperature, depth, and sunlight and light level at specific frequencies while the fish is experiencing its natural environment. And then at a predetermined time, the tag pops up and releases from the fish, pops to the surface, and transmits summaries of these data, which can then be used to recreate the depth and thermal experience of the fish while they were tagged, or more commonly, their location. The aim of this study was to describe the temperature and depth preferences of Meagre in the northeast Atlantic by the use of satellite telemetry. How we did this was through these methods. Meagre were captured as bycatch in a large bluefin tuna trap off the southern coast of Portugal. 6 Meagre were tagged in September 2018, a further 2 in July 2019, and 5 in September 2019. All of the fish measured over 100 centimeters length, and they were tagged with mini-PAT pop-up satellite archival tags, which is a relatively small type of satellite tag. The tags were programmed for different deployment periods. In 2018, they were deployed for 120 and 180 days, while all the 2019 tags were deployed for 300 days. After the deployment period, the pin attaching the tag to the anchor on the fish starts to corrode, which allows the tag to surface, But premature releases are also common and may be due to predation or infection at the anchor site or entanglement, for example. And then when the tags surface, as I said, they transmit data summaries and as well as the tag location. So the physical retrieval of the tag can be attempted. If this is successful, the archived data in the tag can be downloaded, and this consists of time series records with a few seconds between each data point. If they're not found, then the satellite transmitted summary data is downloaded, and this consists of time series with 10-minute intervals between records. The data I used in my study consisted of depth and temperature time series data, and we also used the tagging location to classify records as during the day or night according to sunrise and sunset times, and for comparisons with the sea surface temperature. We had a pretty successful tagging operation. 5 tags were physically retrieved, so we could use the archival data, while 4 were not retrieved, but we managed to get their summary data. And when I finished my thesis, we were still waiting for 4 more tags to pop up. There were some gaps in the summary data, such as missing days. And the sampling range was from only 1 month of data to up to 300 days of data. Due to the sampling period and due to the deployment periods and the tagging date, the majority of our data covers the boreal, autumn, and winter. If we look at the amount of time that Meagre spent at different depths, we have here on the y-axis depth in 10-meter bins, and on the x-axis percentage of time, and this is divided into night in the grey and day in the white. The Meagre experienced maximum depths between 64 meters to 125 meters, but they spent the majority of their time between 30 to 50 meters, except for fish 5, which spent more time at shallow depths, and fish 8, which was at liberty for 300 days, and that recorded the most time at very shallow depths. Overall, it appears that the Meagre spent a bit more time at deeper depths in the day than in the night. If we look at these depths across the different months, we see the signs of a seasonal pattern in depth distribution. In autumn, September and October, the median depth was shallower than in the winter, and except for fish 5, which followed the opposite trend. This seasonal trend seems to mirror the sea surface temperature pattern as well. However, not completely, as if we look at the fish that recorded data after January, fishes 2, 3, and 8, they appeared to swim to shallow depths after winter, but the sea surface temperature remained low. And I just want to remind you that the sea surface temperature is not necessarily based on where the fishes actually were at that time. If we look at the amount of time that the Meagre spent at different temperatures, we have on the y-axis temperature and the amount of time on the x-axis. The minimum temperatures they experienced were between 13.3 degrees to 14.5 degrees, and the maximum temperatures covered a larger range between 19.4 degrees to 24.8 degrees, although they spent the majority of their time at the lower end of this range, between 14 to 17 degrees, and spent very little time below 14 degrees. If we look at the temperature distribution across months, and compared to the tagging location sea surface temperature, which is in this red line, we see a similar seasonal pattern as we saw in the depth distribution. And we see that the winter temperatures are quite close to the sea surface temperature, but the autumn temperatures are not necessarily mirroring the sea surface temperature. We also see that in the February and March, in these cases where the data recorded February and March, the the temperature the Meagre experienced was still also quite low at this time. In general, the depth results support the known preferences of and limits, the known depth preferences and limits of Meagre. However, this is likely to have been affected by the predominant sampling period, which is during the winter, and the observed seasonal pattern that we've seen. In terms of the differences between day and night, this is probably due to diurnal vertical migration, which is commonly undertaken by fish. And it's possible that Meagre were following prey such as the European anchovy, which does undertake diurnal vertical migration. But there's reasons why the difference was not very large. Could be, for example, that I included the twilight periods in calculating the difference between day and night. Furthermore, our results do seem to support the literature saying that Meagre go offshore into deeper waters during the winter. And we have the slight suggestion that of the beginning of a spring spawning migration in the few fish that were recorded data after winter. This was further confirmed by, I looked at maps made by colleagues of the preliminary tracking locations of these fish. And for example, fish 8 was heading straight for the Guadalquivir spawning estuary in Spain, while fish 3 was going straight for the Tejo estuary in Portugal, where they also spawn, which is supporting that they were already starting their spring migrations as early as February and March. The temperature also supports the literature on Meagre temperature preferences. While they mostly experienced the lower end of this temperature range, this is also probably a consequence of them being sampling the winter. One thing that we are questioning is why they were occupying deep waters in the winter, because in the winter, often the water column is very mixed, meaning that the temperatures at the top and deeper down are very similar. So if they supposedly prefer warmer temperatures, why would they go to deep water? It's possible that they were following the prey such as the European anchovy, which descend to even 400 meters deep in the winter. However, it's also known that Meagre limit their feeding at temperatures below 15 degrees, which is the temperatures they were experiencing in winter. So it's also possible that they were bioenergetically limited in the winter and weren't feeding at all. It's also worth noting that they began their movements to shallow waters in the spring, even though the spring temperatures they were experiencing were still quite low. Apart from the limitations I've already mentioned, having the geographical location of the Meagre would have really been interesting, because this would have allowed me to relate the depth and temperatures they're experiencing to the habitat they had available to them, and maybe make some inferences about habitat use. Furthermore, it would have been great to be able to look at influences such as the lunar cycle or the time of day and the sea surface temperature on their depth and temperature records.
2 minutes.
Thank you. To perhaps also maybe identify if there is indeed a trigger for their migration. The cost of the tags is a big limitation in studies such as these, and it results in a smaller sample size a lot of the time. Also, the patchy data meant that there's certain cases where a few records or a few days are representing a whole month, which is obviously something we want to avoid. In conclusion, this study is the first to empirically validate the depth and temperature preferences of Meagre. The results can provide relevant information for understanding the exposure of Meagre to fishing gear, assessing their population numbers, interpreting trophic level studies, and predicting the ways in which climate change is affecting them. This study contributes to the knowledge gap of Meagre behaviour outside of their spawning season, and although the relationships between depth and preferences are still unclear at this time. I want to say thank you to my supervisor, Dr. David Abekasis, the rest of the BCorv team, and the Argyrosomus regius who involuntarily contributed to this study. Thank you so much for listening.